Okay, let's talk about greatest common factor. So the greatest common factor is the biggest number or the biggest variable that can go into two or more different things. So for example, if I have the number, let's say 16 and 24, and I want to know what the greatest common factor between these two numbers are. Well, let's look at what factors I have. My factors here, I have 1 and 16, 2 and 8, 4 and 4. That's what gets me 16. 24, I have 1 times 24, 2 times 12, 3 times 8, 4 times 6. So my greatest common factor for these two numbers is the biggest number. So I have the biggest number here is 16. I don't have a 16 here. Biggest number here is 8. Oh, 8 and 8. So we would say 8 is the greatest common factor of 16 and 24. It's the biggest number that can be divided into both of those evenly without having a decimal. So I can also do greatest common factors with variables. So say I have x to the 12th and x to the 16th. Well, this is saying, right, x times x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's x 12 times. That's saying there's 12 x's there multiplied. And the same thing with this one. This is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16 x's all multiplied. If I was going to start crossing off, right, I can take 1 here, here, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12. Oh, okay, I can only have 12 because guess what? That's my smallest number. That's my greatest common factor. I can divide this by 12 x's and I can divide this by 12 x's. The variable ones are actually very easy because all you have to do is look at the smallest power. So if this is x to the 12 and this is x to the 16, 12 is smaller than 16. So that's my greatest common factor. So for these two, just look, which number is smaller? 12. So x to the 12 is the GCF of x to the 12 and x to the 16. So for expressions, we sometimes have just a greatest common factor that's a number. Sometimes we just have a letter, and sometimes we have both. So for example, I might have something like this. I might have 9x squared plus 3. So what I like to do when I find a GCF is I like to draw parentheses around what I have and draw division signs underneath, because that's basically what you're doing. You're going to divide each term by something. So if I look here, this has an x squared, this does not have an x. If there is not a letter on both terms, or if you have 3 terms or 4 terms, if there's not a letter for every term and the same letter, then there is no variable GCF. So I can't take out x's if I don't have them. So yeah, this one has 2, but this one has none. So there's no variable as part of my GCF. But I do have these two numbers here. I have 9 and 3. The best thing to do if you're looking for a number GCF is start by testing the smallest number that you have. So my small number is 3. So let's see, can I divide 9 by 3? Yes, that's my GCF. A lot of the times your smallest number ends up being your GCF. Not all the time, but a lot of times. So I'm going to divide each of these by 3, and I have to write that on the outside. So that means my answer here, when I take out the GCF and I factor it, the GCF is 3. But most of what you're going to have to do involves actually dividing everything by the GCF and still having an expression. So my GCF is 3. I divide every term by 3. So what I get is 9 divided by 3 is 3. I'm not doing anything with the x, so it's still there. And then plus 3 divided by 3 is 1. And when I multiply this back out, I should get the original problem. Which also means if I have 2 terms in my original expression, there should be 2 terms in my factored form. So let's look at another example. Let's say I have x squared plus x. So I don't even have any numbers here. So there's definitely no number GCF here, but they do both have the same letter. So I draw my parentheses, draw my division signs, and again, you're looking at your smallest exponent, which in this case is 1, right? There's kind of an invisible 1 by that x. So that means I can take 1x from both of these. So that's my GCF. My GCF is x, and I'm going to be dividing each term. X squared divided by x, right? That means I have 2 x's on the top, 1 on the bottom. That leaves me with 1x on the top. This, x divided by x. Same number divided by same number is always 1. It's not 0. And again, this is that same rule of if I start with 2 terms from my initial expression, inside my parentheses after I factor, there still needs to be 2 terms. And if I multiply this out, I should end up with my original, which I do. All right, let's try one that maybe has both. So let's say I have, let's see, 8x squared plus 4x, let's see, how about minus 16. So again, I can see that they don't all have x's. So I know I'm not going to have an x as part of my GCF. But I do see even numbers for all of them. So I know that I could divide them all by 2, but remember we're looking for the greatest common factor. So is 2 the greatest common factor? Well, remember I said you should always check the small number? So my smallest coefficient here is 4, and I can divide 8 by 4, and I can divide 16 by 4. So again, we're looking for greatest common factor, not just a common factor, but the greatest common factor. So this one turns out to be 4, which means everything gets divided by 4. Same, can cross it out. So my answer is 4 on the outside. This is 8 divided by 4 is 2. I haven't done anything, so the x squared is still there. 4 divided by 4 is 1, so I just have plus x. 16 divided by 4 is 4. So here's my, so again, this one, my GCF is 4, and here's my factored version of it, and if I multiply back through, I do get the original. Sometimes there is no GCF. If I had this, x squared plus y. So I have no coefficients, so I have no number part of the GCF, and I don't have the same letter. So I have no letter part of a GCF. So that's it. I don't have a GCF. I can't factor this. So this one would be known as a prime polynomial. I can't factor it. This is, if I said to factor this, this is your answer.